Welcome back to the Blazor Server In-Depth course. In this lesson, we're going to be looking at the page code support. Basically, how to get C# onto our Blazor pages. How does that work? What are ways we can make it better? And how do we configure it? All right, so let's go to Visual Studio. And we're going to create a new project. Go to Blazor app, call it Blazor app, and we're going to call this page code demo. Again, make sure you have 3.1, Blazor server, HTTPS, hit create, close out this main page. And now let's look at what our pages support. Let's look at the counter page, because this is a good, simple example. We've seen this page in action before. We have just a little bit of HTML code here that says, hey, there's a current count, there's that number, and by the way, here's a button. If you click this, it's going to increment the count, which calls this increment count method. And a couple of interesting things to note here. First of all, this code section is right on our HTML page, which is a little bit bothersome. It kind of mixes the two together, and while it's nice to see both, the reality is we really want them separated in some way, otherwise it just makes one big jumbled mess. But beyond that, also note the increment count, that's a private void. So private means that it can only be accessed on this same page. So we're calling private methods that really are on the server when this lives on the client, and that works. And that's because of signal R in between doing that call. But that private is still for this entire page, even though part of it lives on the client and part lives on the server. So this is how you do code. You just say @code and then have your open and closing curly braces, and then any code in here is accessible by your HTML page and you can run it. So notice @current_count, well, that's that private int. That's just a number, and that's being displayed right on our HTML page. And the onClick is for increment count, and that's calling this method, and that increments the number by 1. So there's code that's kind of mixed in this HTML, but it's all calling from this @code section. Now you could leave your code right here, but if we look at the fetch data page, notice how the HTML scrolls down, and then we have even more for code. Now the code's not a lot, there's only 4 lines of code there, but, or 5 lines of code, but still, if we had a real page here, you would think to be even more than that. And so you'd be scrolling all the way down through your HTML and then scrolling again through your C#. And so it doesn't really benefit us to have the code on the same page as our HTML. Plus the fact that it doesn't seem like it'd be that easy to do unit testing. Now it's actually not terribly difficult, but it is something to consider, is maybe we do something different with our code. So let's experiment on the counter page. The first way to make this better or change this would be to put this into its own class and then inherit from this class. So let's create a new class. So we're going to right click on pages and say add new class. And yes, this is just a regular old C# class. And let's call this counter base. And then in here, what we can do is we can move all of the code from our code section of the counter page. So I'll Control X here, I'll eliminate these lines, and I will paste them in here. Now, this will work if we do a few tweaks to it. First of all, we have to inherit from component base. If I can spell it correctly, and control dot to add the using for Microsoft.ASP.NET Core.Components. So that's step 1. And then step 2 is we need to change private to protected. And now over on counter.razor, we can say at inherits counter base. All right, and that's going to inherit from counter base. Takes a second, but those red squigglies go away. And now if we run this, let's make one quick change, which is to, let's call this, let's say plus equal 2. That the count goes up by 2 every time. We know it's still running, but it also is different, so it's not just saved a cache copy or something weird like that. All right, so we'll run this. Once it loads, we'll go to counter. We'll click it, and notice it's now 2, 4, 6, 8, 10. That's doubling the number that it used to be. Instead of 1, 2, 3, 4, it's now counting by 2s. So that does work. So that's one way of having a code behind. Notice there's no C# code in my page anymore, except where we're pulling in the values from the C# code or calling a method. But the actual code is in counter base. Okay? So counter base, what it is we created a class that inherits from component base, and then we inherited from counter base. So we inherited all of this code. We had to make these protected because of the fact that we're inheriting. Let's see what happens if we change them to private. And you run this again, and we get the build errors because it's inaccessible due to its protection level. So when you inherit from something, you can't have it be private. You have to make it protected. So that's kind of a downside. Now let's talk through, before we move on to another method, the method that I prefer, let's talk through what happens if you want to bring in a logger. All right, so how would you bring that in to your page? Well, you can't inject it here because what's the purpose of injecting it on this page when you really want it here? And this is the base, not the page that inherits from the base. So we need to bring it into the base, but you can't bring it in through the constructor. So how do you do that? Well, what you do, you create a prop iLogger control dot to add the using statement and say counter base. And then we would call this log. And it's still not, we didn't do the control dot correctly, I guess. There we go. Now we have the using statement for Microsoft.extensions.logging. So now we have this log, and now we can log things properly. So log information. The new value is counter value, like so. And now it should log every time as a new counter value. Let's make sure it works. I'm going to move this over on the screen, but I'm going to shrink it down so you can see this output window down below. Go to counter. We click there, and it says value counting null parameter logger. Oh, forgot one thing. So you can't just bring it in as a public. We've got to actually decorate it with inject. There we go. Let's try it again. So the inject says, hey, you need to inject this value. So counter, click me. Notice the new value is 2 down here. There's our new values as we click it. So now we have this being injected properly. So use that inject decorator over our property. So instead of saying at inject here, we decorate a property in our base, and that will get injected by the dependency injection system. The benefit this provides is this is now very easy to test with unit testing. Since this inject is here, we don't have to, we can ignore that property or that decorator when we're doing unit testing. And we can actually put our own logger in manually before we call the increment count just to make sure it's logging properly, or you can even just ignore those logs by having a logger that's just an empty logger that does nothing. Okay, so it's definitely possible for us now to replace that dependency with a replacement of our own and now test this method. Okay, so now we have a little bit more testable base class. I might even want to make this public to make it even more testable, but this, like I said, isn't my favorite way of doing things. This has been the way of doing things, but now with .NET Core 3.1, there's an even newer way that's, in my eyes, a little simpler. So let's go down to the Fetch Data page. Let's close these pages out. The Fetch Data page, this Fetch Data is really a class. That's how it's seen inside of C#. So what we can do is we can right-click on Pages and say Add, New Class, and call the same exact name, Fetch Data. Now it's going to yell at us at first and say, you can't do this, there's already a class there. But we can say public partial class fetch data. And what a partial class does is it allows you to merge two classes together. Well, fetch data is already a partial class. So now we just add this to it, which means that basically it's like it's one big class, which means that I can really just cut this out and I could paste it in here, and it's like it's on the same page. Now I need the using statements here. So using the data, there we go. But now I can take the using statement off of here. I can take the inject out. I'll move that over if I want to, but I don't have to if I don't want to. Because for example, let's just run this right now. All it is move some of my code over to the fetch data class and add a using, and it still works. But I can say, no, you know what? I don't want to put C# code here. So I want this forecast service to be injected. So I take it off of there. And now in here, I say prop, and that was a, what was it called? Weather forecast service. So weather forecast service, like so. And now I want to make sure that this is inject or injected. Let's run this. Once it loads, fetch data, data still works. Okay? So this makes things a little easier, I think, because now we don't have to even make these public. They can be private because this is now directly on this page, essentially. Like I said, these two pages are basically one as far as the compiler is concerned. What happens in the partial class during compile is it takes those two pieces or more, you can have multiple partial classes if they have the same name, and it puts them together as if they're one class. It kind of appends them together. So really a partial class is more about helping you see just what you need to see. And so it's really up to you how you do it. And sometimes you might mix these, where maybe you normally do a partial class, but for one page where you have, let's just say we had one variable. Let's make it explicit. So private string welcome message equals hello everyone. Okay? And we just did this. And that was the only C# code in the entire page, which all it's going to do is say hello everyone instead of hello world. But it doesn't make sense to have a whole partial class just for that. So it makes sense just to do this. But as it grows, you might want to switch over to a partial class. But as you saw, it didn't take much to do that. Just create the partial class and then pop everything over and you're done. So whatever way you choose, just know you do have options. And I do encourage the idea of separating out your C# from your HTML and Razor syntax. I like that separation. It allows for better visibility and better understandability, and it allows for you to even put those two side by side if you have a big monitor or if you split the screen, and now you can look at the code with your layout. All right, so just do something like this where you say new vertical document, and now you have your fetch data over here and your fetch data over here. This is the HTML, this is the C#. So now you can kind of work both together. Okay, so that's how you deal with code in C# and in Blazor pages. Now, what code you put in here, that's really up to you. But here's what I would encourage. I would encourage you to only put code that directly relates to displaying data on your page or calling for other data. That's it. So your code, however you structure it, whether you do the code behind it, you do inherits, or right in the page, the C# code on your Blazor page should be just enough for and just about display, because it's UI code. And I get this question a lot. It's like, okay, well, how do I do data access in Blazor? I know how to do it in Razor pages, but how do I do it in Blazor? Well, it should be the same exact way, because you shouldn't be doing data access here. You do data access somewhere else, and then you call it from here. So the somewhere else can be a class library or even just a class somewhere else. I would recommend a class library, and we'll do that when we do data access. But just note that you don't, this code right here, this code, you wouldn't put this right in your user interface code. That doesn't make sense. Separate it out. Let your user interface code be just about user interface stuff. So when it comes to this code, it should be things like, hey, what message do you want to show there? Or when we click this button, what should we do? All right. And even increment count, that really, if it was doing more than this, I'd have it call another service, because you don't want to have all this logic code in your user interface. You want to call somewhere else and have a logic code there. All right. Keep those separations. That way your user interface is as small as possible, and it's just about what's unique about Blazor, because that way, if you decide to build a Razor Pages website instead, or if you decide down the road that you want the Blazor client side, then the differences are small enough that you don't have to redo your entire app, just your user interface, and maybe not even all of that. All right, so that's it for this lesson. We've covered how to write our C# code in our page, whether it be right on the page using that @code section, or whether it is a class that we then inherit from, or as my preference is, we have a partial class that's the same name that now just kind of merges right in with our Blazor component. Okay, so either way you do it, this is how you separate out your code or work with your code at least inside of a Blazor page. Give it a shot, try it out, try it 3 different ways. Make sure you understand how to wire each of them up, the pros and the cons, and kind of get comfortable with whatever way you think is probably best, but still try the other 2 because you'll probably have to do those other 2 along the way. Okay? So with that, give it a shot, and when you're done, come on back for the next lesson.